Hi everybody, I'm going to show you today one method of how to find out if two fractions are equivalent to each other. Now let's start off by just saying that equivalent means equals. So they are equal to each other, equal in size or equal in amount. So I've got my bar model here and I'm going to use it to show you how you can find out if two fractions are equivalent. So what I'm going to do to start with is I'm going to draw for you a rectangle and I'm going to draw it over this hole. So I have my one hole here. Now anything that is the same size as my rectangle, which is equal to one hole, will also be equal to one hole. So for example, if I move my rectangle down here, you can see that 1, 2, 3, 4, 5/5 is equal to one hole. So that would be written as 5/5 is equal to one whole. Now, easy, because we know that whenever the numerator and the denominator are the same, it is equal to one whole. So in fact, all of the fractions here we have are equal to one whole. Now, what if I want to find a fraction that's equivalent to a half? I'm going to move my rectangle so it's the same size as a half. Okay, so now I can use this rectangle to decide which of my fractions here are equivalent. So if I look at 1/3, you can see that 1/3 is not equivalent to 1/2 because the lines are in a different place. If I move it down here into the quarters, what we can see is that 1/2 is the same size as 2/4. So if I was going to write that as a calculation, I would now know that a half is equal to 2/4. Okay, let's have a look at if there's any more. So if I move it down to the fifths, I can see that it's not quite the same. But if I move it on to the sixths here, I can see that it is the same. So now I can also say that 1/2 is equal to 2/4, which is also equal to 1, 2, 3 over 6. And I bet I could also find that it was equal, it would also be equal to 4 over 8, not anything over 9, 5 out of 10, and I think that is 6 out of 12. So we've used the bar model to find out that all of these are equivalent fractions. I'm going to show you one more time using a third. So I'm going to make my rectangle the same size as 1/3. So I'm going to use this bar model now to find out what else is equal to 1/3. Of course, this only works if you've equally cut your bar models into the correct amount of denominators. So for example, the denominator of a third is 3, and this is split into 3 parts. Denominator for 8, the denominator for an eighth is 8, so this bar is split into 8 parts. If that is not done equally, you will not be able to use this bar model method. So I've got my 1/3 here. It's not equal to a quarter, not equal to 1/5, but there we go, it is equal to 2/6. So using this, I'm now able to say that 1/3 is equal to 2 over 6. And let's see if we can just move it on any more. It's not equal to 3/8, but it is equal to 3/9 there, we can see. So I can also add that 1/3, 2/6 is also equal to 3 over 9. Okay, so now you've got these numbers, I'm going to have a look at some patterns for you. So I've written these out a little bit easier for you to see. So as well as using the bar model, you will notice now that there is a pattern between these numbers. Now here, for example, the numerator goes up in ones, 1, 2, 3, and the denominator goes up in twos, 2, 4, 6. Now what we need to do to find out if these are equivalent is to find out what happens to this? Which operation would we do to 1 to get to 2? And that should be the same operation that we do to 2 to get to 4. And if that number then becomes equal, then we know that they are equivalent fractions. I'm going to try to add 2 more on the end here using this method. So when we're finding equivalent fractions, we never use plus or minus. We never use addition and subtraction. We only ever use multiplication or division. So what do I have to multiply 1 by to get to 2? I have to multiply 1 by 2 to get to 2. So here I have to multiply 2 by 2 and it gives me 4. Okay, this one doesn't go into here, but if I see here I've multiplied 1 by 3 to get 3, and I multiply 2 by 3 and that gives me 6. So if I was to multiply 1 by 4, I would get 4. And if I was to multiply 2 by 4, I would get 8. So there is the next equivalent fraction in the sequence. So I can do it again. If I was to multiply 1 by 5, I would get 5. And if I was to multiply 2 by 5, I would get 10. So those are the next multiple. So if you have one, for example, that is 2 over 5, you would know that it doesn't fit into this sequence and therefore is not equivalent to a half. Let's try it down here. So what have we done here to get these numbers? So here we have multiplied 1 by 2 to get 2, and we've multiplied 3 by 2, which gives us 6. Here we've multiplied 1 by 3, which gives us 3, and we've multiplied 3 by 3 to give us 9. So to find the next one, we are going to multiply 1 by 4, which gives us 4, and then we are going to multiply 3. We're going to multiply 3 by 4, which gives us 12. Now we can check if we're correct there because we've still got equivalent rectangle, so we know that's equivalent by 3, and if we move it down to the 12s, we can see there that in fact 4 over 12 is equivalent to a third. I hope this helps.